Okay, testing. Okay, hello everyone, senior geography students. Okay, today we're going to continue our study on the Unit 2. And today we're going to discuss how do the fluvial process shape the land. So before, we have already introduced what are the fluvial process. So they are erosion, transportation, and also deposition. And today we're going to talk about like how do those fluvial processes that may shape the land, and we're going to focus on the features, the geographical features on the upper course. So therefore, you may prepare your textbook. Okay, you may prepare your textbook. Unit 2.3. Okay, Unit 2.3. So today, first, we're going to talk about like what type of landscape would be result in the upper course due to the fluvial process. Before we go to the textbook, okay, so you may have a look for the background picture today. Actually, this is a landscape in the upper course, okay, and that one we can call it Interlocking Spur. Although you may not observe any large river in this area, but okay, from the shape, for example, from the spur here, okay, spur here, okay. Of course, there will be more spur, okay. You may know that that is a feature that is called interlocking spur, and it will mainly occur in the upper course of the river. And today we're going to talk about like how do the fluvial processes, how does like erosion that may lead to or that may shape the land like this. So therefore, you may prepare your textbook, okay, Unit 2.3. Okay, first, on here, okay, here you can see that what features that could be found in the upper course for the landscape or the features in the upper course. So please highlight, okay, please highlight those. Please highlight those landscape. Okay. In the upper course, okay. So the features, the first one, we call it V-shaped valley. Okay, V-shaped valley. The second one, interlocking spur. The third one, rapid. Okay, rapid. The fourth one, waterfall, and also gorgeous. Okay, so these are the features that could be commonly found in the upper course. So for the first one, V-shaped valley. So what is V-shaped valley? Okay, you may have a look about the figure 4. So the formation of V-shaped valley. So V-shaped valley, you may understand that that could be like for the normally the river valley, but we would add like the shape of the valley. It could be in V-shaped. Wide, there will be the V-shaped valley. It is because in the upper course, okay, so please mark this, vertical erosions or what we call or like down cutting that would be active, that will be very active. So I hope you still remember when we mentioned the process of erosion. It can be divided into like vertical erosion, lateral erosion, and also headward erosion. In the upper course, vertical erosion that would be most common. Therefore, when the river valley, under the influence of vertical erosion when the river valley become deeper, or the shape of the valley that become a V-shaped, then that would lead to the V-shaped valley. And V-shaped valley that is mainly occurred in the upper course. If you observe in the lower course, is there any V-shaped valley? Not exactly. Okay. For example, you may look at like figure 4, like what should be the formation of a V-shaped valley. First, there must be a vertical erosion. So therefore, the riverbed that would become deeper. Okay, so the riverbed will become deeper, and then on both sides of the river, okay, like this part, it will be weathered away. And you can see that, okay, in your textbook it mentioned weathering that would occur. So when those material that is carried away by other agents such as like water or winds, okay, if they're removed, so the shape of the valley, it will become V-shaped, and that is what we call the V-shaped valley. So remember, V-shaped valley that is mainly occurred in the upper course. So that would be the first one. Okay, and then for more information, when the V-shaped valley that's continue to develop, okay, you can see that due to little energy at the upper course, okay, little energy at the upper course, the river actually it is unable to cut through the obstacle such as spur. Okay, so this one, such as spur on this part, as like spur for the size, I would say that would be much larger. So therefore, the river may not be strong enough, okay, to cut through those obstacles. Then the river is then forced to zigzag from side to side around this obstacle. Okay, so this one that could be a little bit complicated to understand. So therefore, we may use the figure, okay, to demonstrate this. You may have a look for figure 5. Okay, you may have a look for figure 5 here. First, let me draw where would be the valley. So when we read the map, okay, when we read the contour map, okay, so you can see that there could be like the valley. Oh no, the spur. Okay, the spur, not valley, the spur. As the spur, that would be relatively large scale. So therefore, the water or the river that cannot cut through this. Then, if you look at this, so the water, okay, flow to this direction, okay, that would flow, okay, when the water meet the spur, okay, as the energy would be relatively low, therefore, it will flow away, okay, as the water cannot erode away those parts, and then when it meets another spur, flow to another direction and form this. This is what we call the zigzag move, okay, the zigzag form. So therefore, after that, we may see that vertical erosion lower the river channel, and then the spur will become more distinct, and interlocking spur is formed. So therefore, interlocking spur actually that associate or that exists together with the V-shaped, not exactly the V-shaped valley. So in the upper course, that is when the water flow, okay, as the water that is with just little energy. So therefore, the water cannot cuts through the spur, then flow it in a zigzag form, and finally form that interlocking spur, like this, Figure 5b, Same. So from the source, the water flowed, okay, from the high ground to the low ground, and here you can see that is the spur. That is the spurs. And then one spur and other spur, or you may look at figure 5c here. Okay, one spur on one side and other side, like this. And this one, that is what we call interlocking spur. And we may expect that the water that may float in this way. So therefore, the first feature, together interlocking spur and also the V-shaped valley. Then the second type of landscape in the upper course. So rapid, waterfalls, and also gorges. So rapid in Chinese, we may call it 一啲嘅急流啦，一啲嘅激流啦。Waterfalls 瀑布啦， and also gorges. You should know that like 峽谷啦。So how does this feature form? How did this feature formed? Okay, so please highlight this first. So there must be a criteria. Okay, so for the formation of these three features to be formed, that is about the geology. When there's existing of the more resistant rock and then less resistant rock. So that could be like layer. For example, imagine that. So that is the surface. Okay, we stand on the surface like this. Okay, honestly, okay, if you stand on the ground, you may not know the rock type, okay, under earth, but in fact, there could be like different type of rocks underground. If the place that is with the alternative layer of the different resistant rock, for example, okay, one layer and other layer, okay, again like this. So imagine that. Okay, so if that would be more resistant rock and the layer with dot less resistant rock. Okay, we may say that due to the external forces, so like erosion or weathering, less resistant rock will be eroded easily. So therefore, if there's any agents, okay, of erosion like this, less resistant rock that could be eroded easily, then it may form a different landscape, and that kind of layer that may lead to the formation of rapid, waterfall, and gorges. So let's have a look first for the rapid. So just now we have mentioned there must be more resistant rock like this, resistant rock, and less resistant rock. You can see that would be in layer. And if the less resistant rock that is erode easily, okay, so by the river, by the water, therefore that may lead to the change of the landscape, such as like this. So you may have a look for the step 1. So less resistant rock erode more quickly than resistant rock that lead to sudden drops. Okay, you may highlight sudden drops in the new riverbed, and it may create some steps. Okay, some steps. So due to the different resistance of the rock. So therefore, this step in the riverbed that may break up the flow of the river. So therefore, when those steps break up the flow of the river, those waterfalls that may flow faster at the steep gradient, or we may say that may flow at the step, okay, and it may increase the turbulence, then it will form the rapid. So rapid, why there will be rapid in the upper course? This is because there, so along the riverbed, there could be some great steps, and those steps with steeper gradient and the water that may flow faster, then it would create the turbulence. Okay, 會產生一啲嘅急流、湍流啦。So therefore, that would be like the formation, okay, of the rapid. So therefore, here that would be about like the explanation in paragraph when there's, okay. So you should, when we understand, when we have to understand what would be like rapid, there must be like a steps. When there's a large step in the landscape or in the relief of the land, river will fall down to form waterfall. So compare to rapid. Just now we mentioned rapid, that is a steps. But next, waterfall, large step. Okay, you may imagine that like waterfall, that would be a larger scale rapid. So when the last step, okay, so water will fall down to form waterfall. So the falling water at the waterfall produce strong hydraulic action, forming a circular pool of water at the base of the waterfall that called punch pool. So I will explain it later. Continued undercutting of the less resistant rock caused the overhanging resistant rock to lose support. So therefore, it may collapse under gravity. This process continues, and over time, waterfall retreat to form a narrow, steep-sided valley called gorge. So therefore, that would be like the relation. So right now, let's do the drawing together. Let's do the drawing together. Okay, that is not really good for the background. Okay, imagine that would be like a slope, for the first one, rapid. For the rapid, so if the water flowed from the high ground to the low ground, okay, is there any rapid? Of course, no. Okay, so when we say a wide rapid occurred, that is, there must be like this. Different layer of the rock resistant. Okay, so two types. More resistant rock. less resistant rock. Less resistant rock. So when the less resistant rock that is erode easily by the water, okay, by the flowing water, like this. Like this. Okay, maybe here as well. So therefore, the water will then flow like that. Okay, the water will then flow like that. There will be steps, different steps, and it will cause, that will lead to the turbulence, and that is what we call the rapid. So therefore, this is the first one for rapid. Then the second one, waterfall. Waterfall, that would be like this. So that would be easier. Okay, so imagine that would be like a slope. Okay, and the water that is flowing along the slope. But if there is a resistant rock here, okay, more resistant rock, and here less resistant rock, okay. So when the water that flowed first, this part, it will be eroded away, and then on the downstream, that part, it could be eroded. If the erosion that takes place continuously, here, maybe the whole part, maybe here, it will be eroded. So therefore, the new landscape that would be like this. The new landscape that would be like this. Okay, and the water will flow at this point and flow to downstream. And you can see that when the water that's flow here, at the bottom of the waterfall, that would experience a very large hydraulic action, okay, the force of the flowing water. So therefore, again, for this part, there will be also the vertical erosion that may take place. And after this is this part erode, okay, and a new features that would be formed at the bottom of the waterfall, and we would call it punch pool. Here, punch pool. So therefore, for most waterfall, you can see that nearly most waterfall, at the bottom of it, you can see a punch pool. Why? This is because when the water that flow from the top, it creates strong hydraulic action. So therefore, that may create a pool at the bottom, okay, of the waterfall. So therefore, it will be the whole landscape, waterfall, together with punch pool. So normally they are in pairs. When you see waterfall, you will see punch pool. So the second one, waterfall and punch pool. And punch pool. Okay, then the third one, gorgeous. Okay, let's go back to the textbook first. For gorgeous, I would say that it's relatively difficult to understand. Why? You may just have a look for the paragraph. Continued undercutting of the less resistant rock caused the overhanging resistant rock to lose support. It collapsed under gravity. This process continued, and over time the waterfall retreat from a narrow, steep-sided valley called a gorge. So from the paragraph, I would say it could be a little bit complicated to understand, like, what is a gorge. So therefore, okay, for the drawing of a gorge, so this time I will draw like a 3D model like this. Okay. That is terrible. Okay, I draw a curve like this. Okay, imagine that there is a waterfall here. Water that flowed in this direction, and then waterfall and flow to downstream. And we may know that there could be like a layer, okay, resistant rock layer here. Something like this, but that is not the most important. Okay, just a layer. So remember, when there's waterfall, it may more likely to lead to the formation of gorge. Okay, it may. I use the word may. First, where does the erosion take place? The erosion takes place. That would be at that part. The red area. So just now in your textbook, it mentioned a process. Okay, we may call it undercutting. I would say for undercutting, it is a kind of vertical erosion. So therefore, for vertical erosion, it means that the river bed, okay, the river bed, it will become deeper. So therefore, what does that mean? That is when this part, when the red area, if there's any undercutting, it means that, okay, so process number one, and then process number two, okay, it will become like this. Okay, this time I'm not going to draw the river. It will become like this. Okay, it will become like this. So the water that may flow at that point and then waterfall. But in case, okay, if we want to know more about like the formation, and you can see that that would be the undercutting. If this process continue, if this process continue. Okay, so this area will become deeper. This area will become deeper. And this, the area between both sides, we would call it narrowed, steep, okay, and deep valley. And this is what we call like a gorge. So therefore, over the time, waterfall retreat to form a narrow, deep, steep-sided valley called a gorge. So why the waterfall retreat? It is because, can you see a waterfall here? Not exactly. It is because the waterfall that may retreat to the source. Okay? Or if this is like long enough, so the whole area that will be long. So that is what like the similar to the formation of Shansha or the three gorges. 三峽啦，我哋學過長江三峽，三個峽谷。Okay, so that is also formed by the river like this. So therefore, that would be about like the gorge. Okay, then in Hong Kong, is there any waterfall? I would say in Hong Kong, actually, there's a lot of waterfall. One of the famous waterfall you can see it would be in Tai Po in Sun Leung Tam, the Bright Pool, and also Jiu Gang Tam. That is a very, very famous waterfall in Hong Kong. And then in your textbook, you can also see in Lam Shun, the upper course of Lam Shun, Lam Chun Ho la. So in the upper course, you can see a place that is called Tong Zai la. You can also see there is a waterfall, and the punch pool at the bottom. Okay, so therefore that is about like the formation of waterfall and punch pool. And then here on page 39, okay, you can also see that that is like a map reading skills. Can we observe any waterfall in the map? Of course, yes. Okay, but what would be a waterfall look like? Okay, in a map. So please mark the first point. If you look at a map, when the contour that is closely spaced or merged into another one, like a cliff, okay, when most contour line that is very compact, okay, we can observe there must be a very, very steep slope. Then, if there's water, if there's river, we may conclude that it is a waterfall. Okay, so therefore the first one, a contour are closely spaced, and the second one, river cut across the closely spaced contour. Then that would be a map evidence that shows there must be a waterfall. So therefore that would be about some map reading skills. Okay, and in your textbook on the next page, so you can see that that would be the diagram that to show how waterfall that is formed, that is similar to my drawing. Okay, so like the first one, when the river flow over a layer of resistant rock, followed by a layer of less resistant rock. Okay. Then the less resistant rock erode more quickly and form a step. And rapid erosion continue less resistant rock, making the depth larger, and water falls down from a waterfall. Remember, you must mention the hydraulic action for that one. And then after that, strong hydraulic action undercuts the back and the base, forming a notch. So what is notch? So the back here, that is what we call notch. Okay. Later, when we study like the coastal erosion, we will also talk about like what is notch. Notch normally that would be at the back here, and form a punch pool there. Okay, punch pool there. So when the erosion continue, or when a notch that is developed or enlarged, the resistant rock, okay, overhang that may collapse. So therefore, somehow we may say it, but it takes a relatively long time. Okay, so the waterfall that may retreat upstream. If this process continue, okay, a gorge will be formed. Okay, a gorge will be formed by the retreated of waterfall. So therefore, you can see here. So a gorge may also be formed by strong down cutting at the upper course, such as at just now we mentioned in the Shansha in China, Samhabla. Okay, when down cutting process faster than the lateral erosion, a deep, okay, and narrow valley with steep side is formed, and that is what we call the gorge. 呢個嘅峽谷啦，呢個就係。Okay, so therefore, we move to the checkpoint already. It means that we have already finished the part for the landscape in upper course. So here comes to the summary, okay, or the conclusions. So what do we talk about? What do we study today? So that is how do fluvial process, okay, shaped the land. That is our topic. Okay, so today we talk about the example in the upper course. The example of the landscape we have studied. So we have the Vshaped Valley, and also Interlocking Spur. Okay, Interlocking Spur, and we have also learned the rapid waterfall, together with the punch pool, okay, and also a gorge, That is the landscape we have studied. Okay, so what would be some important point we need to note? First, just now we talk about how do the fluvial process that may shape the land. So we need to identify what fluvial process, okay, so that would occur mainly in this area. Of course, it must be erosion. But for the erosion, make sure you know that would be like the vertical erosion. Or we have always mentioned that we called it down cutting. down cutting or undercutting, as it may mainly taken place at the riverbed. Okay, so that is the fluvial process, together with the geology, together with the rock that may lead to the formation of rapid waterfall and also gorge. We must also talk about like the type of rock, but of course not exactly the type. Okay, we must focus more that is like the resistant, that would be better, resistant of rock. If the rock layer in that place that is with different resistance, such as like more resistance or less resistance, you can see different layers. If there's different layers, okay, in that place, so rapid, waterfall, and gorge, that would be easily seen. Okay, so therefore that would be about the summary for unit 2.3 for the first part about the formation of those relieved under the fluvial process in the upper course. So therefore after that, okay, so please finish this 2 checkpoint exercise. Okay, so we're going to check the answer later, and then next lesson we're going to talk about the landforms or features that is formed at the middle course. Okay, so therefore that's all for today. So if you have any questions and problems, okay, please refer to the email and to the phone number, or you may leave the comment in the channel. Okay, so I will answer your questions as soon as possible. Okay, so therefore this is the end of this section. Okay, so I will see you in the future. Okay, goodbye.